Hello everyone. Tonight we're going to be discussing medians and altitudes, two special segments in triangles. First we have the median. A median of a triangle is a segment from the vertex of an angle to the midpoint of the opposite side. So as we see, here is our median. So it goes from this top vertex and splits our base in half. So each of these are congruent to each other. Let's look at a median example. So if CD is a median of triangle ABC, then find X. Well, if CD is a median, that means it must hit AB at the midpoint, so these two segments must be congruent to each other. So that means that BD is equal to AD. Now, if I set my two pieces equal to each other, then that gives me 6x plus 7 equals 4x plus 11. Then I'm going to subtract 4x from both sides, and that would give me 2x plus 7 equals 11. Then I need to subtract 7 from both sides, and I have 2x is equal to 4. Then when I divide both sides by 2, then I find that x has to be equal to 2. Next, we have a special point in a triangle called a centroid. This point is the point of concurrency of the three medians of the triangle. So that means the place, if I draw all three medians, they will all intersect at one point. The centroid is the center of gravity of a triangle. So what that means is if you cut out the triangle, you could balance it on your pencil at that point. And last, we know that the centroid is 2/3 the distance from the vertex to the midpoint. So what that means is the distance between the centroid and the vertex is twice the distance between the centroid and the midpoint. And this is true of all three medians. But we don't know if the medians are the same size or not, so that's why I've labeled them 2x and x, 2y and y, and 2z and z, because the length of the median depends on the type of triangle that you have. Tonight we are also discussing altitudes of a triangle. The altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. So for example, if we have an acute triangle, then if I'm drawing in the altitude, it's going to go from the vertex down to the opposite side and make a right angle. And in acute triangles, you'll find that the altitude is always inside the triangle. On a right triangle, we will find that the altitude is actually on the triangle, because the perpendicular line from the vertex to the opposite side is the leg of the triangle, so it's already a piece of it. And then last, if you have an obtuse triangle, the altitude is going to be on the outside. So this is what it means when it says the line containing the opposite side. So on an obtuse triangle, if we draw a line straight down that's perpendicular, it won't be inside, it'll be outside. And so we just extend our base with this dotted segment. It's not part of the triangle, it's outside, just showing this is what would happen if I extended this line. So obtuse triangles will have an altitude that is outside of the triangle. Altitudes also have a special point. It's called the orthocenter. The orthocenter is the point of concurrency of the three altitudes of the triangle. So if you look at different types of triangles, in an acute triangle, the orthocenter will be inside the triangle. In an obtuse triangle, the orthocenter will be outside of the triangle. And in a right triangle, the orthocenter is going to be on the triangle. So you have different options of where your orthocenter could be located in, on, or around your triangle. And I'm sure by this point you're thinking, how am I supposed to memorize which segments make which special points? Well, we have a funny phrase that we use to help us remember this. Our funny phrase is, an odd peanut butter cup may contain apple butter instead. So if you look at the first letters of each of the words, it tells you which segments align with which points. So we start off with an odd. Well, that stands for altitudes orthocenter. Then we have peanut butter cup, and that stands for perpendicular bisector circumcenter. May contain is median centroid, and then apple butter instead is angle bisector incenter. So this is a phrase that can help you remember which segments make which special points. And that is everything for this video. See you in class.